What's up, guys? I have a bit of a different video today for you. It's not all about video games. This channel is mine, so I can do whatever I want with it, really. Um, Basically, I like talking about stuff that I think is interesting. Not necessarily cool, but I think it's cool. So it's my channel. I do what I want. Basically, today I was in my microbiology lecture, and we were going over batch culture systems, which is basically how uh, microorganisms react in a little petri dish, which is a little closed dish where they can like eat nutrients and whatever and be happy for a while. Basically, I lost control of what she was saying, or I didn't have control of what she was saying, but I lost track of what she was saying because she showed me a graph. She showed us a graph, even showed us a graph, and it follows something strange. Um, I have my notes here, so I'm going to go through the notes, and hopefully, if this works, I'll have an overlay of the graph, so you can follow me along um, as I'm talking. So, basically, it starts off. There's four phases. There's the lag phase, the log phase, the stationary phase, and the death phase. So basically, it starts off with the lag phase, which is a period of adjustment to new conditions, where there's little or no cell division occurring. Population size doesn't increase really. It's a phase of intense metabolic activity in which individual or organisms grow in size. It may last from 1 hour to several days, depending on the history of the organism, where it came from, or if it's going into a new media, and it'll also depend on the generation time of the actual organism itself. Then after it leaves the lag phase, it goes into the log phase. In this phase, the cells begin dividing and generation time reaches a constant. It mightn't be its perfect generation time, and it mightn't be its worst generation time, but it's the same time for every generation, really. Basically, this is the period of most rapid growth, where the number of cells produced are much greater than the number of cells dying. Cells are at their highest metabolic activity in this phase, and cells are most susceptible to adverse environmental factors at this stage, such as radiation and antibiotics. After the log phase, it goes into the stationary phase. This is where it kind of levels out. Population size begins to stabilize. Number of cells produced is the same as the number of cells dying. Overall cell number does not increase, and cell division begins to slow down. Factors that slow down microbial growth are accumulation of toxic waste materials. The acidic pH of the media changes due to these toxic waste materials. There's a limited nutrients since they've been eaten by so many microbes just living there and eating all the nutrients, really. And there's an insufficient oxygen supply because every little microbe needs oxygen to survive. Basically, after a while, it's just the population size begins to decrease because there's just so many of them. The number of cells dying outnumbers the number of cells being produced by a vast amount. Cell numbers decrease at a logarithmic rate, which is exponentially downwards, which is pretty fast. Cells lose their ability to divide after a while, and after a few days of this, only a few cells might remain alive for a long period of time. So basically, you get a little bit. It goes high, comes across again, and then it just falls, and just everything dies off. This correlates exactly to human population on the Earth. Like if we take the Earth, I know there's a major difference between correlation and causation, and that's a whole other topic. I know that there's no relationship at all. It's not scientific fact. But we're both living organisms, and these four phases happen with every microorganism you put into a petri dish, more or less the same exact thing. And if we take the Earth as, just say for argument's sake, take the Earth as one big petri dish, and I'm not sure of the actual times, but At one point there was a population in the world of about 1 million, and that went on for a very long time. 1 million humans, by the way, so just we're talking humans here for argument's sake. There was a population of about 1 million humans in the entire world, which I know is tiny by these standards, but you know, log scales. So basically after a while people started to settle, we adjusted to our environment, and basically we multiplied like hell. And at the moment we're in our log phase, if you're talking in terms of the microbiology here. We just got out of our lag phase, which was the 1 million population, which went on for thousands of years with 1 million people, just a straight line across. That was it. So now we're in our log phase, which is kind of terrifying, and people are saying there's way too many people. I've heard jokes about we need a new plague and stuff. So yeah, it's kind of scary. Thing is though, the log phase will probably go on for a hell of a lot time more. So, a hell of a lot more time actually. Never mind my bad English. But hopefully we'll all be dead before before we reach the stationary stage. And even if we reach that, the stationary stage in microbes at least goes on for a long time. So it'll just be like an equal steady line a lot above, maybe around 18 billion or something, some ballpark figure like that. Then everyone's going to die. So, well, not everyone, there might be like 500,000 left living in under the earth, like mole people. But yeah, so yeah, don't feel down about it though, because hey, we've got space, and eventually we're going to terraform Mars, and that's going to be awesome. So yeah, don't feel down. I just thought this was interesting. And also, Goat Simulator is out tomorrow. Go get that. Thanks for listening, guys. Like, subscribe, comment, and yeah, I know this isn't exact science, but I thought it was interesting what was going through my head today. So comment if you want to talk to me about it, or talk amongst yourselves, whatever. See you guys. Thanks.